On April 14, 2026, World Quantum Day, something strange happened on Wall Street. A quantum computing startup called XNDU jumped 29% in a single trading day. IonQ, one of the biggest names in the field, rocketed up 20%. SEALSQ, Rigetti, D-Wave. The entire quantum sector lit up like a Christmas tree. Billions of dollars flooded into companies building machines. Most people couldn't explain if their lives depended on it. What triggered it? Not a breakthrough from any of these quantum companies. The fuse was lit somewhere else entirely by a company that has never built a single quantum processor. NVIDIA, the AI chip empire, they announced a gift to the quantum computing world, completely free, completely open source, and the market absolutely lost its mind. On the surface, this looks like generosity, the most valuable chip company on the planet helping its struggling cousins cross the finish line. But stay with me for the next few minutes, because the real story is not about generosity. It is about one of the most brilliant pieces of strategic chess in the history of technology, and almost nobody is talking about what is actually happening underneath. Let's start with something you might not expect. The name itself, NVIDIA called this new family of models Ising. That is not a random word. In 1925, a young German physicist named Ernst Ising published a toy model of magnetism. A simple lattice of atomic spins, each pointing up or down, each tugging on its neighbors. At the time, it looked almost trivial. Ising himself thought the model was a failure. He was wrong. Over the next 100 years, his little lattice became one of the most powerful tools in all of physics. It describes phase transitions, neural networks, even social dynamics. And here is the beautiful twist. The mathematics of quantum error correction, specifically the decoding problem for the surface codes that most labs actually use, turns out to be almost identical to the mathematics of the Ising model. Same equations, completely different universes. So when NVIDIA names their quantum AI Ising, it is not just a cute reference. It is a signal flare to every physicist in the world that says we see the connection and we are about to exploit it. Which brings us to the real question. Why would NVIDIA, a company worth trillions, suddenly launch free AI models for a totally different kind of computer, one that is supposed to one day make classical chips obsolete? To answer that, we need to understand the dirty little secret of the quantum revolution. Quantum computers are astonishing on paper. A classical bit is either 0 or 1. A quantum bit, a qubit, can be both at once, a property called superposition. Imagine a coin spinning on its edge. While it is spinning, it is heads and tails simultaneously. Entangle many of these spinning coins together, and the computer can explore an exploding tree of possibilities in parallel. In theory, this could break modern encryption, design new drugs, simulate exotic materials, problems classical computers would need 1,000,000 years to crack. In reality, qubits are unbelievably fragile. That spinning coin, the moment anything touches it, a photon of heat, a vibration, even a cosmic ray from outer space, it falls. The quantum magic collapses, the calculation is ruined. How bad is it? According to NVIDIA's own director of quantum product, the best quantum processors on Earth today make roughly 1 error for every 1,000 operations. That sounds tolerable until you realize useful quantum computing needs something closer to 1 error per trillion operations. That is a billion-fold gap. There are only 2 ways to close it. The first is calibration. Every single qubit has its own quirks, its own resonant frequency, its own drift. Keeping them all in tune is like conducting an orchestra of 1,000 instruments, where every instrument quietly detunes itself the moment you turn your back. Traditionally, this takes a room full of PhD physicists, days or even weeks, staring at measurement plots and nudging microwave pulses by hand. The second is real-time error correction. While a quantum algorithm is actually running, the system has to detect and fix errors faster than they accumulate. We are talking microseconds. Miss the window, the errors cascade, and the whole computation falls apart. Both of these are hellish problems, and they are the walls that quantum computing keeps crashing into. This is where NVIDIA Ising walks in. The first model, Ising calibration, is a vision language model with 35 billion parameters. Think of it as a virtual PhD physicist. It looks at the raw measurement plots coming off a quantum processor, the same squiggly graphs a human expert would stare at, and figures out how to retune the hardware. What used to take a team of experts days, this thing does in hours. And on a purpose-built benchmark called Q-CTRL, It outperformed every frontier model out there, including Gemini, Claude, and GPT. A real story makes it concrete. A company called Q-Control plugged Ising into their system and used it to wake up a 21-qubit quantum processor completely from scratch, with zero human tuning. Along the way, the AI automatically detected and worked around hardware components that human experts had already declared broken. It noticed things the humans had missed. The second model, Ising decoding, handles the error correction side. It is a 3D convolutional neural network, the same family of architecture that powers self-driving cars, retrained to watch quantum error signatures in real time. Up to 2.5 times faster, and 3 times more accurate than the open-source decoder the entire industry has been using for years. And here's the kicker. NVIDIA released all of this, the models, the weights, the training framework, completely open source under Apache 2.0. Anyone can download it, anyone can fine-tune it, free, forever. Which brings us right back to our question, why? Here is where most people stop reading. They see the headline, NVIDIA helps quantum industry, and move on. But if you look a little closer, you will see one of the oldest and most elegant plays in the strategy playbook. Economists call it commoditize your complement. The idea is simple. Every product has a complement, something that becomes more valuable when the other is cheap and everywhere. Hot dogs and buns, cars and gasoline, operating systems and applications. If you sell hot dogs, the cheaper and more plentiful the buns, the more hot dogs you sell. In NVIDIA's world, GPUs are the hot dog. Quantum processors one day are going to be the bun. Because here's what almost nobody outside the industry realizes. Even when quantum computers finally work, they will never work alone. They are so fragile, so noisy that they need a massive classical computer, a GPU cluster, constantly babysitting them in real time, running calibration, running decoding, crunching terabytes of data per second just to keep the qubits from falling apart. One industry estimate says that a single full-scale, useful quantum computer will generate around 100 terabytes of error correction data every second. That is more data than Netflix streams to the entire planet. So NVIDIA looked at this landscape and made a decision that is almost too clever. They said, we will not build quantum processors, too hard, too risky, too many competing physical approaches. Instead, we will build the brain every quantum processor needs to survive, and we will give that brain away for free. Because every quantum machine that runs on Ising is also a quantum machine that needs a stack of NVIDIA GPUs sitting right next to it. Now, here is where it gets really cunning, and it is worth slowing down for. Before Ising, there was a genuine debate in the quantum world about what kind of chip should actually run the error correction. Many experts assumed the answer would be custom silicon, FPGAs, or ASICs, because traditional decoding was a graph matching problem. It involved walking through nodes, making branching decisions, jumping through memory in unpredictable patterns. GPUs, for all their raw power, are actually terrible at that kind of work. They prefer long, predictable streams of math. If that path had won, NVIDIA would have been quietly locked out of the quantum revolution entirely. So what did NVIDIA do? They did not try to make GPUs better at graph matching. They reinvented the problem itself. By using deep neural networks to do the decoding, they converted the branchy, irregular graph problem into pure tensor multiplication. And tensor multiplication is what GPUs were born to do. It is the one thing they do better than anything else on Earth. Think about that for a second. NVIDIA did not try to win the game as it existed. They rewrote the rulebook until they could not lose. And there is one final layer. Yes, Ising is open source, anyone can download the weights, but to actually run these models fast enough to keep up with a live quantum computer, you need extreme low latency hardware. Microseconds matter. The only interconnect on Earth that can feed data to Ising fast enough is NVIDIA's proprietary NVQ link. 4 microseconds of round-trip latency, 400 gigabits per second, wired up through NVIDIA's CUDA-Q software stack, running on NVIDIA GPUs. When the company Quantinuum ran this full setup in a real experiment, connecting their Helios quantum processor to an NVIDIA Grace Hopper chip through NVQ-Link, they hit a median decoding time of 67 microseconds, fast enough to push corrections back to the qubits before the quantum state collapsed, and the logical error rate dropped by more than 5 times. Concrete experimental proof that the whole pipeline actually works. So yes, the model is free, but it only really runs on NVIDIA hardware. This is the same playbook that made Microsoft rich in the PC era. Give away the standard. lock up the substrate. So who wins and who loses? In the short term, the quantum startups are celebrating. NVIDIA just solved two of their biggest problems for free. It is a real gift. It adds years of runway. But long term, it is complicated. These companies spent years telling investors they would be full-stack pioneers, not just hardware but the operating systems, the developer tools, the whole experience. By adopting Ising, they are quietly surrendering the most valuable layer of that stack. They risk becoming what PC makers became in the Windows era: interchangeable, margin squeezed, while the real money flows to the platform underneath. And the full-stack giants, IBM and Google, who dreamed of being the Apple of quantum computing, their story is being unbundled in real time. Just weeks after Ising, IBM announced an expanded partnership with NVIDIA. The tide, it seems, has already turned. To be fair, Ising is not magic. Deep learning models famously struggle when real-world data does not match what they were trained on. Real quantum hardware has weird correlated noise, thermal drift, leakage errors, all the messy things that training simulators tend to idealize away. The benchmarks look great, but as systems scale from a few hundred qubits toward millions, the real-world results are still an open question. NVIDIA is not claiming that quantum computing is solved. They are claiming that when it is solved, it will run on their platform. Those are very different claims, and that, in the end, is the deeper lesson. This is how NVIDIA plays. They do not bet on which technology wins. They design the game so that whichever technology wins, they win with it. Superconducting qubits runs on NVIDIA, trapped ions runs on NVIDIA, neutral atoms, photons, something nobody has even invented yet, runs on NVIDIA. The quantum industry was so obsessed with the race between qubit technologies that it forgot to ask who would build the road underneath. NVIDIA built the road, then they gave it away, knowing full well that every traveler would eventually need to stop at their gas stations. When Jensen Huang said, "AI is the operating system of quantum machines," that was not marketing, that was a flag being planted. We may look back at April 14th, 2026, not as the day quantum computing got a helping hand, but as the day quantum computing quietly became part of NVIDIA's empire.